Hey there, fifth graders. Let's get some more practice in adding and subtracting our fractions. So let's take a look at this problem up here. We have 1/2 plus 1/5. And if you can look at the example, it shows that it turned them into tenths. So just a reminder why is because when this one here started out as 1/2, and then we drew the fifth line in, we got tenths. And the same up here. We started out with 1/5, and then when we drew that half line in there, we got all of our tenths. So why did they decide to use tenths to solve this problem? Because 2 and 5 both go into 10. So we're going to think about when the units went from halves and fifths to tenths, what happened to the size of the units? Well, this is what happened to 1/2. So we have our 1/2, and remember, do it to the bottom, got to do it to the top. That's what we have to remind ourselves when we're converting fractions. So to turn halves into fifths, we had to multiply by 5, and we got 10. Did it to the bottom, got to do it to the top. So 5/10. I want to remind you, this is very important. When we did this, we're not doing 1/2 times 5. We're just converting it into tenths. 1/2 and 5/10 are the same thing. Half of a pie and 5/10 of a pie is still the same amount of pie. You are not changing the value of the fraction. So we're going to write an equation like that one to explain what happened to the fifths. So we have 1/5, and we're turning it into tenths. Well, to turn a 5 into a 10, we multiply by 2. Did it to the bottom, got to do it to the top. So we get 2/10. So then we would add it together. So that looks like this. So right here we have our 1/2 and our 1/5. But we converted it to tenths, so we know that's really 5/10 plus 2/10, which would equal 7/10. Now, are there other units we could have used besides tenths? And another way to think about that is, do 2 and 5 have other common multiples? Well, let's see, 5, 10, 15, but does 2 go into 15? No. But we could have used 20ths, because 2 and 5 both go into 20. But that would have been a little harder and more work, so we'll just stick with our tenths. So let's try that out with our 20ths. So let's see, 1/2 to convert it to 20ths. Well, to make that 2 into 20, we're multiplying by 10. Do it to the bottom. Got to do it to the top. So we have 10/20ths. And then for 1/5, let's see. What do you have to do that 5 to turn it into a 20? We multiply by 4. So now we have 4/20ths. So our equation becomes 10/20ths plus 4/20ths, which is 14/20ths. So is 14/20ths the same amount as 7/10? Because remember, 7/10 is what our first answer was for 1/2 plus 1/5. Well, check this out. 14/20ths. Can I convert this fraction to something else that would mean the same? That would be the same amount of pi? Yeah. So we've got 14/20ths, but we're going back down. So we're going to divide bottom and top by 2. 14 divided by 2 is 7. 20 divided by 2 is 10. Hey, we're back to 7/10. So something I want to show you is, let's think about it like this. We're going to draw ourselves a pizza. And we're going to divide our pizza into 10 pieces. Okay, I know it's a little ugly, but that's 10 pieces. And we're going to shade in 7. 1, 2, 3, 4, 5, 6, 7 of them. Now let's decide, we had more people do our pizza party. Now we need to divide it into 20 pieces. So that's 14/20. 14 out of the 20 pieces. Is that the exact same value as the 7/10? Yes, we just divided them into smaller pieces, so we would have to have more of them to get the same amount of pizza. So 7/10 and 14/20 mean the same thing. They're different ways of expressing the same fraction. Let's take a look at problem 2. 1/2 plus 2/3. So how does this compare with our first problem? We have a 2 in the numerator. So not just ones, now we've got a 2. But what can I predict about our answer? Well, 2/3 I know is more than half. 2/3 of a pizza, more than half a pizza. Plus a half, I bet our answer is going to be greater than 1. So let's take a look. So let's see, halves and thirds. What can we turn them into? Here, I'm going to make a list over here. I'm going to count by 2s, 2, 4, 6, 8, and then I'm going to count by 3s, 3, 6, 9, 12. Do I have any numbers in common? Yeah. So I'm going to turn them into sixths. So let's see, to turn my half into sixths, I multiply by 3. And to turn my thirds into sixths, I multiply by 2. So let's see. 1 times 3 is 3, 2 times 3 is 6, 2 times 2 is 4, 3 times 2 is 6. 3 sixths plus 4 sixths equals 7 sixths. Hey, is that greater than 1 like I thought it was going to be? It is, because the numerator is bigger. So we're going to turn this into a mixed number, because that's just neater. So let's see, I know that 6 sixths would be 1. So if I took that 6 sixths out, then I have 1 sixth left for 1 and 1/6. Let's check out this one. So how does this problem compare with our others? Bigger numerators. We've got 5s now, folks. 5s. So here it tells me to find the sum. So that's a good reminder, because I know that sum is adding. So let's see, I have 9ths and 6ths. Can I add 9ths and 6ths? No. So what am I going to turn them into? Well, let's start. We'll count by 6, 6, 12, 18, 24, 30, 35. Okay, and then we'll count by ninths, or excuse me, by nines. 9, 18. Stop right there, because look, I have 2 numbers that match. So it looks like I will be turning my fractions into 18ths. So 5 ninths equals how many 18ths? We're going to multiply by 2 to find out. Looks like we've got 10 18ths. Plus, let's see, let's convert our sixes. 5 sixths equals how many 18ths? Well, 6 times 3 is 18, so we'll multiply both by 3. 5 times 3 is 15. So we have 10 18ths plus 15 18ths is 25 18ths. Are we done? Heck no, because that's still an improper fraction. So I'm going to take 18 of my 18ths and turn them into a 1, and then I still have 7 18ths left over. Let's try the last problem, please. Now look at this last problem. It's got 3 addends, thirds, fourths, and halves. So how's this going to affect our approach to solving? Well, we're going to have to turn them into a new unit that 3, 4, and 2 can all go into. So let's see. We'll start with 2s, 2, 4, 6, 8. Then 3s, 3, 6, 9, 12. And then 4s, 4, 8, 12. I don't see any that all 3 have in common yet, so maybe I'll go a little further. 10, 12. Hey, there it is. They can all go into 12ths. So let's see. 2 thirds into 12ths. 1 fourth into 12ths. And 1 half into 12ths. So let's see, here we have to multiply by 4. Here we have to multiply by 3. And here we have to multiply by 6. So let's fill in our numerators. 2 times 4 is 8. 1 times 3 is 3. 1 times 6 is 6. So our new problem, we have 8/12 plus 3/12 plus 6/12 equals 17/12. So let's pull out 12 of those 12ths and turn them into a 1. And 12/12 taken away from 17 leaves us with 5/12 left over. So what patterns have we observed about the common units? They're always multiples of the original. So we use multiples, just like 12 is a multiple of 4 and 3 and 2. And something else I noticed, we can skip count. We can count by 2s or 3s or 4s, or whatever our denominator is, to find what we need. So will the new unit always be a multiple of the original units? Yes! Yes, it will be. All right, 5th graders, on to your problem set. Good luck.